All right, so welcome to the first Allen Mentoring SAT stream, and actually our first education stream at all. We're going to be starting with SAT Math, and we'll be running through the official SAT Blue Book. So what I actually found out is it's available for free on the College Board website. So if you go to the description, you can get a link to that PDF. And I believe all 7 practice tests in their latest book are available online for free. So that was news to me. And I have the PDF up here. And we'll be running through every single question. Hopefully on all 7 practice tests. This is going to be just math. In the future, maybe I'll be doing a reading, writing stream. And if you have any suggestions for content, please feel free to write in the chat and suggest it. But I think math is pretty popular. People either scared of it or they're not really sure what sort of math will pop up on the SAT. So for my initial kind of surveying and feedback, this was what was requested. And I know that ACT is starting to increase in popularity. So if you're actually going to be studying for the ACT, I promise some of this material is going to overlap, and I may do an ACT stream sometime in the next few months. So yeah, feel free also to hit the subscribe button, and I'll give you a little shout out on stream. And if you have any questions, please write in the live chat. It's going to come at probably like a 25-second delay, so I might come back to a question. But if you have if you're confused at all, just write in the chat and I promise I'll get to it eventually. So let's start with, this is test 1. Again, linked in the description if you want to follow along and work on your own. So here we go. Question 1. If x minus 1 over 3 is equal to k and k is equal to 3, what is the value of x? So in this case, it's pretty straightforward. We want to replace k with 3 because they tell us k is equal to 3. So I'm just going to rewrite the equation. X minus 1 over 3 is equal to 3. And then our job is to isolate x. And in algebra, we know that we want to do the opposite of what's happening to x, and we want to do it on both sides. So we see x minus 1 is being divided by 3. What we want to do is multiply by 3 on both sides. Whatever you do to one side, you must do toward the other. And x minus 1 over 3 times 3 will actually cancel out. So if we multiply a fraction by its denominator, it actually cancels it out. And now we're left with x minus 1 is equal to 9 on the side. And then lastly, we just want to isolate x. Again, we want to do the opposite, which is adding 1. And we're going to do it to both sides. So the final solution is x is equal to 10, which is conveniently found down here. Question 2. So far, so good. For I is equal to the square root of -1, and I is an imaginary number, we see we cannot find the square root of a negative number. What is the sum 7 plus 3i plus -8 plus 9i? And you'll see these a lot. These are called complex numbers. So they'll have some sort of integer, like you see here, 7, and then they'll have an imaginary number, something I. So it could be positive, negative, but it's really simple, and all you have to do is just treat I as any other variable. So if you were combining, let's say, 3x plus 2x, okay, you would just have it as 5x. You could do the same thing with I. So we're just going to combine these two. And so we're going to see that 7 plus 3i, and I'll write that out here without the parentheses, plus, and then we have -8 plus 9i. And so what are the like terms? Well, we see that 7 and -8 are like terms. And then we see, and I'll put these in a different format, we see that 3i and 9i are like terms. And so we'll just combine them individually. We see that we have 7 plus -8 is equal to -1, and 3 plus 9 is equal to 12. So 3i plus 9i is equal to plus 12i. Okay? And bam, we got A as our answer, and we're steamrolling through. Number 3. On Saturday afternoon, Armand sent M text messages each hour for 5 hours, and Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon? Okay, so let's see here. Armand is M. Okay, he sent M text messages each hour for 5 hours. So if we were just talking about Armand's total text messages, we see that he sends M, oops, I don't know what that did, M, and he does it for 5 hours straight. So if it's once each hour, all we have to do is multiply M times 5, okay? So that's Armand, and Tyrone sent P each for 4 hours. So Tyrone would be P times 4. And if we were to combine these, it would just simply become 5M plus 4P. And we see that in choice C. Now be careful here, look at that, they have 4M plus 5P. This would be an easy mistake to make, so you want to be very careful when running through SAT math questions. Sometimes they'll just try to trick you with the numbers more than the actual math itself. And also note that in SAT math, the questions get more difficult as you get through the section. So we'll see that, 1, 2, 3 are pretty easy, 4 might be pretty easy, but as we get into the teens, 13, 14 will be pretty difficult. So stay with me. If these are really easy, you can just fly through these on your own. And then when the going gets tough, you can come back and we'll work through it together. So, number 4. Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P is equal to 108 minus 23D, where P is the number of phones left, and D is the number of days she has worked that week. What is the meaning of the value 108 in this equation? Okay, so let's think about that. So P is the number of phones left. Okay, so number of phones remaining. Okay, and D is the number of days she's worked that week. So her job is to fix phones. So what would 108 be? If P is how many phones are left, and we're subtracting all the phones that she's fixing per day, what do you think 108 would be? Chances are it's the number of phones that she started with in the first place, right? Because if she fixed 108 phones, then she would have 0 left. So it makes sense that 108 minus 108 would be 0. So which one of these says starts each week with 108 phones to fix? That looks right. Right? Because that means she starts with 108 and she gets through, hopefully, gets through 108 by the end of the week. Alrighty. Flying by, number 5. Which of the following is equivalent to the expression above? And we see here we have a pretty hairy polynomial, and our job is just to find the like terms. Because if we can find like terms, we can add or subtract them just like any other x or y. They just are a little bit more complicated. So in this case, let's see. We have x squared y here. Do we see any other x squared y's? Not here, not here. Okay, I see one right there. So that'll be our first like term. The next I see we have is 3y squared, and I'll put a little separate, different symbol here, like a little caret. And then I see we have another 3y squared here. And then lastly, we have 5xy squared and 3xy squared. And when I say like terms, all I mean is that they should have the exact same variables. So if this one has x and this one has y, the other one should as well. And they should also have the same exponent. So in this case, we see x squared y. We have to look for another x squared y, because xy squared would be a totally different term. So now that we have identified the same terms, the like terms, let us try to get rid of these parentheses. So I'm going to rewrite this: x squared y minus 3y squared plus 5xy squared. And I know my handwriting's pretty terrible. And now I want you to check out this trick that is very, very popular on the SATs or in any algebra class. we see here we have a minus in front of a parentheses. So if you're wise, you'll know that in order to remove the parentheses, we have to change the sign of everything inside of these parentheses, right? So if you have a subtraction in front of a parentheses, you have to distribute that to every single sign in the parentheses. So in this case, it's minus minus. So we're going to say plus x squared y, and I'm going to go into the other territory here. Then it's plus 3xy squared. We want to subtract 3xy squared, again, because we're distributing that minus sign. And lastly, it's going to be plus 3y squared. So now, all we have to do is combine like terms. So we see we have x squared y plus x squared y. So that's going to be 2x squared y. So we take care of this, and we took care of this. Next, we have minus 3y squared, and then we have plus 3y squared. Well, that's easy. Minus 3y squared plus 3y squared is actually going to add up to 0. So we're just going to cross these out. Don't even worry about them. Bam. And lastly, we have plus 5xy squared minus 3xy squared. Again, they're just like terms. All right, so we're just going to say bam, 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 bam. 5xy squared minus 3xy squared would be minus 2xy squared. Okay, so let's see here. Oh, yeah, sorry, what am I doing? Plus, right? 5 minus 3 is plus 2xy squared. All right, so we get to see a little hiccup, but we're still going strong. Let's continue. Numero 6. A pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age, a, in years, between the ages 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? Okay, so what is really going on in this model? Well, we see that a is years, okay? So every year, right, boys can get a little taller. But the question is, by how much taller is he going to get? Well, we see, let's plug in some numbers, for example, right? Let's say at the age of 2, he'll be 3 times 2 plus 28.6. Okay? So this will be 6 plus 6 plus 28.6, which will be equal to 34.6. Okay. So the question is, what happens at age 3? Well, we see here that if we plug in 3, the only thing that changes is the number that we're adding to 28.6. All right, and so in this case, we'll be adding 9 plus 28.6. And so we see that every single year, he grows by 3 inches. So 3 here is what he's growing by every single year. Okay, so we can select A and feel pretty happy that we got that one correct. Okay, number 7. This one looks pretty complicated, but don't worry. Remember, if it's early in the section, right, like number 7 is pretty early, then chances are it's not going to be that hard. Okay, so don't freak out when you see all these crazy numbers and fractions and exponents. Okay, so the formula above gives the monthly payment M needed to pay off a loan of P dollars at R% annual interest over N months. Ooh, it's a lot of language. Which of the following gives P in terms of M, R, and N? Okay, so what we really see, we don't have to even know what these figures mean. All we really care about is isolating P, okay, in terms of everything else, right? So we want to leave this P on one side and shift everything else to the other side. Well, this actually reminds me a lot of what we did in question 1. Right, in this case, remember, all we had to do was do the opposite to both sides, right? So if you're dividing by 3, you want to multiply by 3 on both sides. So knowing that, we're going to come back to this problem and see how this applies. So we see the first thing that's bothering P from being by itself is this fraction, right, this denominator. How do we get this denominator to the other side? Well, if it's dividing, right, if P is dividing this, the way we get it to the other side is by multiplying. So we want to see this thing being multiplied. Oops, what the heck did that do? Wait a minute. Okay. We want to see P being, you want to multiply that denominator and put it next to M. Okay, so what we want to see is 1 plus R over 1200 to the n minus 1, this entire denominator just being multiplied by M. So let's go to our answer choices and see which one is that. Okay, so I see actually only B, right? Only B has this giant thing in the numerator, right? It's multiplying by M. Okay, so we kind of actually already know that B is the answer, all right? But let's see how we get those other two, okay? So assuming that we multiplied this by M, what's left over on the right side? Well, we have this guy and this guy left on the right side. So if we want to do the opposite to both sides, we'll see that these are multiplying by P. So to isolate it, we divide those on both sides. So we should see these two in the denominator, okay? So M is dividing these two and multiplying by what we originally moved over. Okay, so in this case, B is the correct answer, okay? And if you want more help with these types of problems, please let me know in the chat, and we could do maybe like a little separate one-off to describe that. Okay, let's move on. If A over B is equal to 2, what is the value of 4B over A? Ooh, that's interesting. And you'll see a lot of these on the SATs where you actually, they give you some sort of variable or fraction equal to a number, and then they modify it somehow. They flip it around, they multiply it, and they want you to get the final answer. Okay, so let's see how to do this one. Well, the first thing is, what do you notice between A over B and 4B over A? Well, first things first is that it's flipped, right? So now let's see here. We have A over B is equal to 2, and we want to somehow flip that to B over A. Well, we can do that, right? If you flip one side, remember in algebra, you can do it to the other side. So if we want to flip 2, think about it. How would you do that? Well, 2 we can rewrite as 2 over 1, right? 2 and 2 over 1 are the same thing. So if we want to flip that, B over A would be equal to 1 over 2. Okay, so now we're starting to get it looking like this modified fraction that they want us to do. So what's left? Well, once we flipped it, we see that 4B over A has a 4 right next to here, right? So if they're multiplying B over A times 4, all we have to do is multiply 1 over 2 times 4. And if we do that, we see that 4 times 1/2 is equal to 2. All right, so in our case, C is the answer. So in summary, for these types of problems, just whatever you do to modify one side, do the same to the other. All right, and eventually you'll find what they want you to get. Okay, so I'll be right back in 2 minutes. Hold tight, and if you have any questions, please feel free to write in the chat. All right. Sorry for the interruption. Get myself some seltzer here. Okay. Let's do this. So, we are on number 9. What is the solution xy to the system of equations above? Okay. Let's see here. Got my pad set up. Okay. Solution. Okay. So, how do you solve a system of equations? There are a few methods. There's the two main ones are elimination and substitution. And I'm not going to go over both right now. That could be a separate video. But in this case, I'm actually going to use the elimination method and show you how it applies for this problem. So let's see here. Let me rewrite the first equation up top. Okay. It was negative 23. Very nice. And I'm going to rewrite the bottom equation. I'm just going to realign. I'm going to kind of put the negative x to the front here. And I'm going to put the 2y underneath the other y. And I'm just doing this to keep a little organized for when I do the elimination step. So, what is the elimination step? Well, we see here we have 3x and we have minus x. If we can actually change this bottom equation to have minus 3x, we can kind of add up these equations like a sandwich and eliminate the x's from the equation. And once we do that, all we have to worry about is the y. Okay? So in our case, what I'm going to do is I'm going to multiply this bottom equation, the entire thing, by 3. And you're allowed to do that, right? Because whatever you're doing to the left side, you're doing to the right side. So this is a totally legit algebra move, and feel free to use it wherever you see fit. So in this case, it's going to be minus 3x plus 6y is equal, negative 19 times 3. Where's my handy dandy? Oh, bam. Okay. What was it? It's, wait, am I allowed to use calculators in this? No, I'm cheating. What am I doing here? Okay, so negative 19. I almost cheated. Okay. Do the 7, the 2, put the 3 here with the bam. Okay. Negative 57, I hope. All right, so now get this guy out of the way. So now here are our two equations. Again, what you're allowed to do is you could add up two different equations, kind of like a sandwich, and then eliminate one of these variables. So we see that once you add these up together, 3x minus 3x gets canceled out. 4y plus 6y is 10y. That's a 0. And then negative 23 plus negative 57, I believe, is negative 80. Okay. And then y, if you divide both sides by 10, divide this by 10, y is going to be equal to negative 8. Very nice. And luckily, if you look at our solutions, B is the only one that has negative 8 for y. Okay? And if by the way, if these confuse you, these are just coordinate pairs. So this is x comma y. So the x solution is going to be 3 if we were to plug this back into those equations. All right. That was a little bit long-winded, but system of equations is an important concept, and elimination is a very useful technique. 10. For the function g defined above, a is a constant, and g of 4 is equal to 8. What is the value of g of negative 4? So I've worked with a lot of students on functions, and they get confused when they see this notation, right? Because we've learned that if you put a letter next to a parentheses, it usually means multiply. No. In this case, g of 4 means that you are inputting 4 into the function g. And the function g is defined here. Okay? We see, what did I just do? Okay, sorry. This thing is freaking out on me. Okay. So they're asking, what is the value of g of negative 4? So let's see what the issue is. How come I can't just plug in? Wait, my mouse is totally not writing here. why can't we just plug in g of negative 4 into this equation? Well, the problem is we'll get things like this, right? We write the a, and then we have negative 4 squared plus 24. It's supposed to be 24. And so what we see is that we have 16a plus 24, but that doesn't get us any closer because we don't know what a is. Aha. So our job is to first find out what a is, and once we do that, then we can plug in negative 4, which we did here, and figure it out. So how can we possibly know what a is? Well, they actually give us a really good hint, right? They tell us that g of 4 is equal to 8. They're saying if you plug in 4 into this function, it should spit out 8. Well, that helps us a lot, because now if we do g of 4, I don't know if you guys noticed, but my pen is starting to write invisible ink, and then as I let go, and then writes as red. So I don't know what I pressed to make that happen, or if it's just lag, but it's kind of tricky here. Okay, so g of 4 is equal to a, and then 4 squared plus 24, and that's actually equal to 16, or sorry, to 8. So this is really useful for us, right? Because now if we solve this out, we see that 16a plus 24 is equal to 8. So we can solve for a. And what is a in this case? Well, let's just subtract 24 on both sides. Bam. And we see that 16a is equal to negative 16. So a must be equal to negative 1. Very nice. So all we have to do here is replace 16a. We replace a with negative 1. And so if we replace this right here, okay, we see that we have 16 times negative 1 plus 24. And so that's going to be negative 16 plus 24, which is positive 8. Woo! Long-winded, a little tricky, but remember with functions, you want to find out the constant first and then only do the final plug-in here with the negative 4. All right, number 11. In the equations above, B and C represent the prices per pound in dollars of beef and chicken, respectively, X weeks after July 1st during last summer. What was the price per pound of beef when it was equal to the price of pound per chicken? Oh, well, that's pretty easy. So we want to know what was the price of beef when it was equal to the price of chicken. So we know that these two equations, at the point where they're interested, are equal to each other, right? The price of B is equal to C. So what we're going to do is we want to set these equations equal to each other, and then we'll find out X. And what does X tell us? X tells us how many weeks after July 1st during last summer. So once we know X, all we have to do is just plug that back in to the equation for B, and it'll spit out what the price is of, oh no, sorry. What was the price per pound of beef? That's what we're looking for. So we'll just put it back into B and see what we get. So first steps first, we want to set them equal to each other. So 2.35 plus 0.25x is equal to 1.75 plus 0.4. Why do my 4's come out as 9s? 0.4x. Okay. So let us get all the x's on one side and all of the numbers on the other. So I'm going to put all my numbers on the left side. So to do that, I'm going to subtract 1.75 on both sides, minus 1.75. All right, and I apologize for the chicken scratch. I promise, as I get used to this numpad, this drawing pad, and the PDF writer, it'll start to get a little better. So what is 2.35 minus 1.75? I believe that is 0.6. Okay. And then we see that 1.75 minus itself is canceled out. And then what we're going to do is we're going to subtract 0.25x from both sides. 0.25x, tiny little. So we see that 0.6 is equal, and what is 0.4 minus 0.25? Well, we can think of 0.4 as 0.40. So what is 0.40 minus 0.25? It'll be 0.115x. All right. And so then last step is to isolate x, and we are going to do 0.6 divided by 0.15. So we're going to actually divide 0.15 on both sides. Bam. 0.15. Okay. So many students get pretty uncomfortable with dividing decimals, and they can be tricky at times. But step one, don't freak out about it. Don't worry. You'll get it eventually. But what's really helpful with decimals is you can pretty much move the decimal in any way that's convenient to you, as long as you're doing it to both decimals. So for example, right, I'm doing 0.6 divided by 0.15. This is a point, by the way, not a whatever it looks like, a minus sign. So this is 0.60, right? 0.6 and 0.60 are the same. If we wanted to divide these two, we could move the decimal place 2 spaces over. All right, we can move it here and then here. And then we have to do the same for the other. So if 0.6 divided by 0.15 was hard, I'm sure 60 divided by 15 is not that hard compared. So what is 60 divided by 15? It is 4, and that is equal to x. So now that we have what x is equal to, all we have to do is plug it back in to the equation for beef. And so we're going to plug it back into this equation. So what is 2.35 plus 0.25 times 4? Well, what is 0.25 times 4? It's basically a quarter times 4 we know is 1. So 1 plus 2.35 is, bam, D, 3.35. Very nice. Number 12. A line in the xy plane passes through the origin and has a slope of 1/7. Which of the following points lie on that line? So if we have, it's going to be a terrible drawing, I can tell you right now. All right, can be worse. We see that a line passes through the origin and that has a slope of 1/7. So we see that rise over run is rises 1 and runs over 7. So it starts here. I gotta stop forgetting about that. Okay. So if it starts here in the origin, we see that it rises 1. Okay, it rises 1 and it runs over 7. So it runs over 7. So the next point, right, would be 7, comma, 1. Oh man, I really thought that was going to be an answer. Okay, we see 7, 1 is not an answer. But if we rise another 1 up here, right, so we're rising another 1, okay, and we're running another 7. So it rises 1 and it runs over 7 because the slope is 1/7. So the next point would be at 14, which looks like 19 at all times. It's going to rise up to 14, comma 2. These 4s have to get better somehow. 14, 2. Okay. Bam. Passable 4. Alrighty. Flying through these. So far, so good. No wrong answers, which is a bit of a miracle. Okay. 13. if x is greater than 3, which of the following is equivalent to this giant mess? 1 over x plus 2 plus 1 over x plus 3. So we see, again, remember I promised that once you get to the teens of this section, it starts to get a little bit more difficult. So this is where you really have to pay attention here and kind of hone your algebra skills. So how do you change a fraction, a complex fraction such as this, to get rid of its denominator? And this kind of has like denominators inside of denominators, right? So it's like an extra layer of trickiness. Well, in this case, we want to find the common denominator of this entire complex fraction. Okay, what denominator will all of these go into? And in this case, it's only 2, right? We only have x plus 2 and x plus 3. And simply enough, we know that if you multiply them by each other, okay, so if you multiply x, oh, my mouse started working again, sweet. If you multiply x plus 2 times x plus 3, okay, we see that x plus 2 goes into this, right, because x plus 2 is a factor, and x plus 3 goes into this, so it works for both. So we see that this is actually a common multiple of both of these denominators. So if we want to multiply by this fraction, you must not forget that you have to do it, you must have the same numbers in the numerator and denominator, okay? Because this whole thing is equal to 1, right? So when you're changing fractions, you must have the same number in the numerator and the same number in the denominator. Okay, so how does this thing work? Well, we see that in this case, right, we're going to look at this denominator multiplied by this denominator. So 1 over x plus 2 times x plus 2 times x plus 3. Well, we see because x plus 2 is the denominator, right, you can kind of cancel out this and this, all right? And so what you're left with in the denominator, we're doing denominator first, what you're left with is x plus 3 here. And in this case, x plus 3 and x plus 3 cancel out, right? So you're left with x plus 2. Okay, and if you don't exactly see what I'm doing here, feel free to write in the chat and I could spend a little bit more time explaining this. But again, all I did was multiply this denominator by this denominator, okay? And this is what I got left in the denominator, okay? And up top, I'm multiplying 1 by this numerator, okay? So up top, I just have x plus 2 times x plus 3. Okay, so what do I have in my denominator here? Let's combine like terms quickly. So we're going to have, okay, this is the numerator. And like terms, x plus x is 2x, and 3 plus 2 is 5. Okay, so we see that B is our correct answer. And so how come the numerators are different? Well, in this case, all they did was they multiplied these two binomials. So how do you multiply two binomials like this? You use the FOIL method. First, outside, inside, last. So we see first times first. Okay, this is f. First times first is x squared. Outer times outer, so that's x times 3 is 3x. Inner is 2 times x, which is 2x. And last is the last two terms. So that would be 2 times 3, which is 6. And if you add up all of these, x squared plus 3x plus 2x plus 6, you get this numerator right here. Okay, and FOIL actually might be a cool idea for a separate video, and we could do some practice problems with that. But feel free to write in the chat if you have any questions about FOIL. Number 14. All right, 40 minutes into this. If 3x minus y is equal to 12, what is the value of 8 to the x over 2 to the y? Whew, this is a tricky problem. And the reason for that is you have to see kind of what the SAT people, what the College Board people are pushing you towards, right? Like, how are you getting 3x minus y? How are you combining this information with this information? And that's one of the toughest parts of the SAT, I'll be honest. I've taken tons of these practice tests before, probably, I don't know, hundreds of problems, if not thousands. So I can kind of already see what they're hinting at. But if this is your first time doing SAT, or if you're like pretty, you're not that confident in algebra, you might not see it right away. But what'll set you off is that you see that 8 and 2 are involved here, and that exponents are involved here. So right away you should be thinking, okay, what do I know about 8 and 2 and exponents? Well, you should see that 8 is actually 2 to the third power. So if I was to rewrite this fraction right here, all I would do is rewrite 8 as 2 to the third, okay, and that's still to the x power, over 2 to the y, 2 to the y. That is supposed to be a y. Okay, so let me actually write that a little bit bigger. 8 to the x over, wait a minute. 8 to the x over 2 to the y is actually equal to 2 to the 3x over 2 to the y. And we see where this is starting to come in now. If you're dividing exponents that have the same base, right? So 2 to the 3x and 2 to the y both have 2 as a base. So if you're dividing exponents that have the same base, you can actually just subtract the exponents. And so you'll see that this will be equal to 2 to the 3x minus y, right? And if you were not familiar with dividing exponents or how to change 8 into 2 to the thirds, this might throw you off a lot. Okay, so I don't blame you if you didn't see this at first. But now we see where they're getting at with 3x minus y is equal to 12. So we can just replace this with 12, and this becomes 2 to the 12th, which is a. Okay, so a little tricky, but if you start doing these practice tests a little bit more, I promise you'll pick up on these patterns, especially with like 2, 8, you'll see like 32 gets thrown in there a lot, and so right away I want you to be thinking, oh, it's 2 to the something. Okay, number 15. Let's see, do I have my notes on these just to make sure I'm teaching you guys the right stuff? Yeah, this one's a really tricky one. I believe this is the last one. Yeah, this is the last question in the multiple choice section. And so these are notorious for being either difficult or long or tricky or some combination. So I suggest if you get to like 14 or 15 and you really have no idea what's going on, I would say leave it and go to the short answer section next. And then if you have time and you are brave enough to take these questions on, try it out. If you have no time left, do not leave any questions blank. Never do that. All right, you have no penalty for guessing. So pretty much you want to just do an educated guess as best as you can. Okay, and I would say, so like questions like 14, all right, don't blame me if this isn't the case, but from what I've seen, chances are it's not going to be something like D here, where the value cannot be determined. Those are rarely the answer. So if you just had to guess, I would not guess that one. Okay, so that's a little pro tip. Don't blame me if that's not the case, but that's just what I've seen. So 15, if ax plus 2 times bx plus 7 is equal to this, for all values of x, and then a plus b is equal to 8, what are the two possible values for c? Whew. So right away, I'm thinking we probably have to FOIL this the same way that we did in problem 13 here. Okay, so we have to FOIL this, and somehow we have to see how we can get a plus b and change it to, substitute it with 8. And then if all goes well, then we'll somehow have an answer for c. Okay, so in this case, honestly, just looking at it right away, I don't see a clear path for solving. So don't be freaked out if you don't know exactly what to do the second you see the problem. You can kind of work through it, especially if you're coming back to it toward the end. Just try to work through it as best as you can, and maybe something will illuminate in your brain. So let's see here. I'm going to FOIL these, okay, and I'm going to do it pretty quickly. So ax times bx, that's the first times first, is going to be abx squared. Then outer is going to be plus 7a. Inner is going to be bx times 2, which is 2bx. And then last is going to be 14. Oh, what am I doing? Plus 14. Okay. Did I do that correctly? Outer. Oh no, sorry. Outer is 7ax. Okay, so that's probably going to come into play. So it's 7ax. This is an a, and that has to stop happening. Okay. So now looking at this, it's kind of clear to me what they're trying to do here. Well, I see that if we match up these two equations, what I drew down here and what's up here, I see, look, 14, I see 14 here. And if these are equal to each other, then AB should be 15. Okay, so AB should be 15. Okay, because these are the same equations. And then CX, I don't really see how we get CX. Okay, so what we can do is we can factor out x from these two. So we have x times 7a plus 2b. Okay, do you see that? I factored out x from each of these, and what's left over is 7a plus 2b. So I see that 7a plus 2b must be equal to c. Okay, so now we're getting somewhere. 7a plus 2b is equal to c. And then what they gave us is that a plus b is equal to 8. So how do we take care of these three pieces of information, right? This is the gold here. We have 3 equations and 3 variables. We should be able to solve this, okay? If you have the same number of equations as you do variables, you should be able to solve for every single variable. Okay, so let's be smart with it. What are we going to do? Well, here, let's take a plus b is equal to 8. Okay, usually the way you want to work through these is you want to isolate one of the variables. So I'll isolate a is equal to 8 minus b. All I do is I subtract b on both sides. Okay, so if this is the case, then you can plug this back into a different equation. So if I have AB is equal to 15, and I know that A is equal to 8 minus B, so I can substitute 8 minus B times B is equal to 15. Okay, so now we want to distribute B to each of these. So we're going to have 8b minus b squared is equal to 15. So far, so good. Well, now this is actually enough for us to solve for b, right? We have a quadratic equation here. We should be able to solve for b without too much problem. So how do you solve a trinomial like this? So it's a very popular form, and you should be used to this. But the way that you want to solve this is you want to have your exponent actually be positive. So I'm going to bring b to this side. I'm going to add it to both sides. So I'm going to have b squared plus 15. It's going to be, the 15 is going to be here. And I'm going to subtract 8b as well. So I'm going to have b squared minus 8b plus 15 is equal to 0. So I literally just brought these two over to the right side here. Okay, so do I have a space below? Oh yeah, sweet. Okay, that's perfect. So b squared minus 8b, don't worry about this plus sign, plus 15 is equal to 0. So how do I solve this equation? Well, we want to factor it in such a way where we can break them down into there's two solutions to this. All right, and I'm sure you've seen this in your algebra class, right? How do we factor this? We want a number or two numbers that multiply to 15 but add to negative 8. So multiply to negative 15 or to positive 15 but add to negative 8. And in this case, only minus 5 and minus 3 work out. So b minus 5 and b minus 3 is equal to 0. Okay? And if this is the case, we have two solutions for b. Ooh, how interesting. All right, we have two solutions for b. B could either be 3 or it could be 5. Okay, because both of these solutions will make this equation equal to 0. So it could be either of those two things. So what do we do here? Oh, okay, so let's go back. So if b is 3, okay, and we know that a times b is 15. If b is 3, then a must be 5. And if b is 5, a must be 3. Okay, so we see these are the two pairs. So they're asking, what are the two possible values for c? Okay, so let's do them one at a time, right? What if b is 3 and a is 5? Let's take this pair, for example. Okay, if b is 3 and a is 5, we can rewrite this equation here as 7 times 5 plus 2 times 3, and that's going to be equal to c. So that's 35 plus 6 is equal, that's an ugly equal sign, is equal to, how does that keep happening? To 41. Okay, and if we look at our solutions, only D has 41 as a choice. So D is the correct answer. And a lot of times, you know, there are two ways to look at it. If you have one of the choices, is that enough to put it as a solution? I would say in most cases, yes. If you feel confident that the way you solved it is correct and your solution appears in the answer, even without figuring out the other number, you can be pretty confident in your choice. If you're really fast and you have a ton of time, then yeah, sure, try to figure out the other number and see if you're correct. But if you're short on time and if you're feeling pretty good, I would say it's safe to just circle the answer if you have one of the solutions correct. Awesome. So congrats, we just finished the first short answer portion of these this here SAT, or of this section 3, right, of the first practice SAT. Let's go to the short answer now. So short answer, remember again, there's no penalty for guessing, but it's be almost impossible to guess correctly if you have, you know, an infinite number of short answers you can choose from. But still, if you have any sort of hint as to the correct answer, please put down some sort of circle some sort of solution. Never leave anything blank. Never, never, never. Okay. If t is greater than 0 and t squared minus 4 is equal to 0, what is the value of t? So t squared minus 4 is equal to 0. Well, that's pretty easy. We want to isolate t squared, so we're going to add 4 to both sides. And we have t squared is equal to 4. So how do we solve for t squared? You want to do the opposite to both sides. What's the opposite of squaring? It is square rooting. So we're going to square root. So what is the square root of 4? It's actually 2 and negative 2. Both of these are the solutions to the square root of 4, right? Because negative 2 squared is still positive 4. But they told us here if t is greater than 0. So we could actually knock out negative 2, and we see that positive 2 is our only answer. Okay, 17. A summer camp counselor wants to find length x in feet across lake as represented in the sketch above. The lengths represented A, B, EB, okay, were determined to be 1,800 feet. So, okay, so let's try to label these as best we can. So AB is 1,800. EB is 1,400. How does that? I don't understand. Okay, 1,400. BD is 700, and CD is 800. Okay. And we're trying to find out what AE is equal to. And oh, they also tell us that AEB, so this is the same measure as that. Okay. So it's pretty good here. So what we're dealing with in this case are similar triangles. Okay, we see, and how do we know these are similar triangles? Well, to test for similarity, all you have to know is that the triangles have all three angles that are the same measure. So in our case, we see that these opposite angles are equal. Okay, these two angles are equal to each other. And they also tell us that these two angles are equal to each other. So if we know that two angles are the same, then the third angle must also be the same. That's what they call the AA similarity postulate. It's a weird name. But as long as you have two angles that are the same, the third angle must also be the same. And in this case, these two are similar triangles. But we see that they're similar triangles that are kind of like flipped around. Okay, so that BD will be similar, okay, to this BE. Okay, they're going to be similar this way. All right, and so that AB will be similar to BC. And so we see that in this case, these corresponding sides are halves of each other, right? 700 is half of 1,400. Okay, so that means that AE is going to be double of DC. So X will be 1,600. Okay, we see that this little triangle is half of this bigger triangle. All right, so 1,600 is your answer. Sweet. 18. According to the system equations above, what is the value of X? Oh, so more system equations. And in this case, we can also do elimination method. Okay, so how do we eliminate one of these variables? Well, what we can do, so let me rewrite this. X plus Y equals -9. And we see on the bottom, we have X plus 2Y is equal to -25. Well, if I wanted to eliminate, I want maybe the X's to cancel out each other. So what I'm going to do is I'm going to set the bottom equation. I'm going to multiply everything on the bottom equation. Actually, wait. I'm going to multiply everything here by -1. And so that way I'll have negative X cancel out with positive X. And so I'll do minus X minus 2Y is equal to 25. Okay? And so I'm going to add both of these together. And I'm going to get this equal to 16. Here, 25 minus 9. Minus 2y plus y is minus y. And then the x's cancel out. So we see that minus y is equal to 16. So y must be equal to -16. All right, but they didn't ask us what y was. They're only interested in what x is. So we can plug in -16 for either of these two y's. You'll get the same answer. So let's plug it in for the first one. So I'll have x plus -16 is equal to -9. And if that's the case, all I want to do is add 16 to both sides, plus 16, okay? And 16 plus or minus 9 is going to be equal to 7. So x is equal to 7. I think that's the right answer. Yes, it is here. Cool. Okay, 19. In a right triangle, one angle measures x degrees, where sine of x degrees is equal to 4 over 5. What is cosine of 90 degrees minus x? So this goes back to some trig, right? And so we know trig has to do with right triangles. So we see this is the worst right triangle ever drawn to man, but imagine this is good, okay? This is really good. Best triangle you've ever seen, okay? And we see we have x. This is the angle x degrees. And we see that sine of this angle is 4 over 5. Well, if we remember, sine is opposite, right, SOHCAHTOA. I'm not going to go into full trig now. If you're interested, let me know in the chat. But I'm just going to say that sine is opposite over hypotenuse. So we see that sine of x degrees is equal to 4 over 5. So 4 is going to be the opposite, okay? And 5 is going to be the hypotenuse. And if these two sides are 5 and 4, then we know that this other side is going to be 3. This is what's known as a 3, 4, 5 triangle, right? And so you could have used Pythagorean theorem to figure that one out. So they're asking, what is cosine of 90 degrees minus x? So I've seen this a lot, sine of 90 degrees minus x or sine of 90 degrees minus something. When they mention this, what you should be thinking about is actually the other angle, right? This angle will be equal to 90 degrees minus this angle right here, right? Because if this corner here is 90 degrees, that only leaves another 90 degrees for the other two sides, right? So whatever this is minus 90 will be equal to this angle right here. So really all they're asking us, what is the cosine of this mystery angle? Well, cosine, we know, is adjacent over hypotenuse, okay? So in this case, we want to see what is adjacent to this angle. Well, that's going to be 4. And what is the hypotenuse of this triangle? 5. So actually, cosine of 90 degrees minus x is also 4 over 5, funny enough. Okay, and this is true for all triangles. You'll have this relationship. Pretty cool. All right, last question of this test. Okay, if A, and supposedly the hardest of the short answer. So if A is equal to 5 root 2 and 2A is equal to root 2x, what is the value of x? Well, similar to one of the problems we did before, right? They're asking you to kind of modify your original equation into a form that they're asking for. So they're giving us A, but they're asking for 2A. So how do we turn this A into 2A? Well, we multiply it by 2, right? This is going to be 2A here. And if we multiply 2 on the left side, we should multiply 2 on the right side. So what is 5 root 2 times 2? When you multiply a root by a number, you actually only multiply the number outside of the root. So in this case, it would be 10 root 2. Okay? And so now they're saying that 10 root 2 root 2x is equal to 10 root 2. Well, what gives? How do we actually find out? How do we turn this into something that looks like this? Well, how do we put a number on the outside of a root back kind of inside? All right, and the way that you do that is you square it. So if you want to put 10 inside of the root, you actually have to square it first and then multiply by 2. So in this case, it's going to be 100 times 2. So this is going to be equal to root 200. And root 200 is equal to root 2x. Okay, and remember, we could always square root or square both sides. So if we square both of these, we just get 2x is equal to 200. X is equal to 100. Bam. Very nice. And we just ran through the section 3 of the SAT number 1 in the new College Board SAT book. Okay, and the link to that SAT book, it's actually available for free online on the College Board site, and I link that in the description. So if you want to follow along, we're going to be doing section 4, which is the calculator math section. So this is completely no calculator. We're going to be doing the math calculator section, and I will be streaming today until 9. So I'm going to take a slight break here and then come back at you with another hour of SAT math tutoring. So hold tight. I was completely muted. Sorry for that. So we're moving on to section 4, and in section 4, it's a longer section, 38 questions, 55 minutes, which is kind of what we have left for the stream. So I might have to continue on Tuesday, and I'm going to be streaming, by the way, Sundays, Tuesdays, and Thursdays from 7 to 9 p.m. Eastern. So if you want to check out the next stream, feel free to come by on Tuesday at 7 p.m. But yeah, Sunday, Tuesday, Thursday, 7 to 9 p.m. Eastern is the tentative stream schedule. So hopefully it works out for most of you students. So yeah, so section 4 here is the calculator section. It's longer, I guess slightly more difficult, and it encourages the use of calculators, as I do as well, right? So whenever you can use a calculator, make sure to use it, and you'll probably make fewer mistakes in the long run. Alrighty. Number 1, John runs at different speeds as part of his training, program. The graph shows his target heart rate at different times during his workout. On which interval is the target heart rate strictly increasing, then strictly decreasing? So this is more just reading graphs. So where is it strictly increasing and then strictly decreasing? So I see there are a bunch of plateaus here, goes up, then stops and down, but I see right here is kind of where it goes up, then it's straight down. So that's going to be between 40 and 60. Now let me tell you something. These are the easy problems, right? The ones in the beginning of the test, but they're actually, in my opinion, the most important of the entire test, right? You do not want any mistakes on the easy problems of the SAT, right? If you're going to have mistakes, please save them for the really hard problems. Okay, so just because this one is really easy doesn't mean you shouldn't look at it 2 times or 3 times just to make sure that it's correct. All right, so don't sleep on the easy problems. Try to get them 100% correct so that you kind of buffer yourself for the more difficult ones. Okay, number 2. If y is equal to kx, where k is a constant, and y equals 24 when x is 6, what is the value of y when x is equal to 5? So this is a typical direct proportionality problem. We see that they tell us y is 24 and x is 6. Okay, so that should be enough for us to figure out k, which is a constant. So let me replace that. 24. I'm telling you, this thing is not my fault. For some reason, when I draw 4s, they just morph into 9s. I don't know how to stop it, but I'm going to figure it out, I promise, by next stream. Okay, so 24 is equal to 6k. And all I did was replace 24 and 6 for y and x. So what is k equal to? Well, this is easy enough, right? Divide by 6 on both sides. K is equal to 4. And then they're asking, what is the value of y when x is 5? So if I reuse this equation, y is equal to kx, I see that k is 4, x is, wait, what is it? K is 4, x is 5, right? They're asking to, right? They're telling us when x is 5. So y is going to be equal to 20. Very nice. All right. Let's see. Now it's getting a little darker outside. Still pretty light here. If it gets too dark, let me know. I have like a super bright, soft lighting thing that's gonna blind me, but for the sake of the viewers, I will go on. In the figure above, lines L and M are parallel, and lines S and T are parallel. If the measure of angle 1 is 35 degrees, what is the measure of angle 2? So 1 is 35 degrees. Okay, and so we know that alternate interior angles, or sorry, corresponding angles, which means that this angle and this angle are the same. So it's going to be 35. And then S and T are also parallel. So we also have corresponding, this is 35. Right? This corresponded to this corresponded to that. And now we see that angle 2 and 35 are actually part of a bigger, they're supplementary to each other, right? They're part of a bigger 180 degree angle. So if this is 35, what is 180 minus 35? That is 145. And actually, what's pretty funny now that I look at it, 2 is clearly an obtuse angle, right? And if they don't tell you that it's not drawn to scale, you could assume that it is drawn to scale. And so 2 is clearly an obtuse angle, and so D is actually the only choice that's obtuse. So at the end of the day, we didn't even have to go through all of this to figure that out. Oh well. Number 4. If 16 plus 4x is 10 more than 14, what is the value of 8x? So 16, let's translate this into algebra. 16 plus 4x is, so is usually equals, is 10 more than 14. I guess they could have just said 24, right? Because that's 10 more than 14, okay. If that's the case, what is the value of 8x? Well, let's isolate 4x here. So we see we could subtract 16 minus 16. 4x is equal to 8. And so if 4x is equal to 8, what is 8x equal to? So we could just kind of double both sides, and we see that 8x is equal to 16. Very nice. Flying through these, pretty easy. They're going to get harder Don't fall asleep on me. All right, these are what you want to pay attention to. The easy ones, quote unquote, are the ones you want to get right all the time. Which of the following graphs best shows a strong negative association between D and T? So strong negative association. So positive associations kind of look like this right here, right? They're going up in a straight line. All right. This one here has absolutely no association. As D goes up, nothing really happens to T, just kind of all over the place. So this is out. This is out. B also kind of looks like it has pretty much no association. D is a clear-cut example of a negative association, right? As D goes up, T goes down. And so kind of, if you do a best fit line, it kind of goes not like that, kind of like that, I guess, right? Maybe even more through these. Okay, I can't draw. Don't worry about it. All right, you do you. All right, 6. A hospital stores one type of medicine in 2 decagram containers. It's not really a unit you hear every day, decagram. Based on the information given in the box above, how many 1 milligram doses are there in one 2 decagram container? 1 2 decagram container. So this is a clear, this is an easy problem to get wrong, right? Why is it easy? Because it itself is an easy problem that has solutions that are pretty much all similar, so you want to be extra careful when dealing with this. All right, number 5, one of these was obviously the right answer. In this case, you can mess up a little 0 here and there, so you want to be very careful when doing these. Okay, so we have 2 decagram container. So 2 decagrams equal 20 grams. We know that. So how many milligrams are there in 20 grams? But we know that in each gram there are 1,000 milligrams. So 20 grams times 1,000 is going to be 20,000. All right, so I'm pretty sure, I'm confident that D is the correct answer. But I think when I first did it, I somehow got 2,000, and I had to look at it twice. So it's an easy one to get wrong. Number 7. The number of rooftops with solar panel installations in 5 cities shown in the graph above. If the total number of installations is 27,500, what is an appropriate label for the vertical axis of the graph? Okay. So all of these combined are going to be 27,500. So should we be talking about this in thousands, hundreds? Well, tens is probably way too small. We're never going to get to tens of thousands. Hundreds is also probably too small, right? 900 plus 500 plus 600 won't get you there. Thousands actually looks pretty good, all right? Because we have 9,000 plus 5,000 plus 6,000. Yeah, we'll probably get to 27,500. We see that D is definitely incorrect, because if it was tens of thousands, then this one alone, A alone, would be 90,000. And that's already way more than our total here. So we can knock out D, and C looks to be pretty good. Number 8. For what value of n is the absolute value of n minus 1 plus 1 equal to 0? When is this guy equal to 0? Okay, so n... Oh, why am I doing it up here? I'll just do it down here. Okay. What? Whoa. Okay. The absolute value of n minus 1 plus 1 is equal to 0. Okay. I will subtract 1 on both sides, and I will see n minus 1 is equal to negative 1. Aha! We see we've run into an issue here. The absolute value of anything cannot be a negative number. All right, that is what absolute value means. It means how far away are you from 0, right? So it could never be a negative number. Absolute value will always be positive. So in this case, there is no solution for n. Okay? Any questions? Please put them in the chat. All right, moving on. Let's get a little seltzer. Oh man, First stream, only an hour and 20 into it, already the voice is beginning to waver a little bit. All right, got to stick through it. Got to do some vocal exercises. Come back stronger, healthier, more robust on Tuesday at 7 p.m. Eastern. But for now, stick with me, and we're going to get all these correct, and you're going to be an SAT master, guaranteed. Questions 9 and 10 refer to the following information. A is equal to that plus that. The speed of a sound wave in air depends on the air temperature. The formula above shows a relationship between A, which is the speed of the sound wave, in feet per second, and T, the temperature in degrees Fahrenheit. Okay. Which of the following expresses the air temperature in terms of... All right, so for this one, similar to one that we did in section 3, all we have to do is we have to isolate T. We see that T is equal to something in terms of all of the other values. Okay, so how are we going to isolate T? Well, the first thing is we probably want to subtract. So let me rewrite this. A is equal to 1052 plus 1.08 T. So we want to isolate T. So what we're going to do is we're going to subtract 152 on both sides. And so far we have A minus 1052 is equal, we're going to cross this out, 1.08 T. So we're good so far. And then last step to isolate T is we want to do the opposite. What's happening to it? It's being multiplied by 1.08. So you want to do the opposite. We're going to divide by 1.08 on both sides. And if we do that, we see that 1.08 divided by 1.08 cancels out. And so that T is equal to this guy right here, which is equal to A. Very nice. Alrighty. Number 10. At which of the following air temperatures will the speed of a sound wave be closest to 1,000 feet per second? All right. So, which of the following air temperatures? Okay. So we want to set 1,000. Which one of these represents the speed? A is the speed, right? So we're going to set 1,000 to be equal to A. And then we're going to say 1,000 is equal to 1,052 plus 1.08 T. So pretty simple algebra problem, right? Single variable. We're going to do this just like every other algebra problem in the world. We're going to do the opposite to both sides. I'm going to need like a little catchphrase in the future for saying that. Opposite on both sides. We're going to figure that out. So we're going to do minus 1,052 on both sides here. Okay. And we're going to get negative 52 is equal to 1.08 T. Finally get to use the calculator for the first time. All right, so we want to isolate T, and so we're going to do the opposite by dividing 1.08, dividing it on both sides. That's what we do. And so now we want to do negative 52 divided by 1.08. Okay. So, Howard B, opposite on both sides. Could you think of something opposite? Oobs. Okay, I like that. Maybe like oppo. So Howard B in the chat is suggesting shortening opposite on both sides to oobs. It's kind of catchy. So we're going to do 52 divided by 1.08. So 52 divided by 1.08. That's going to be equal to about 48. Okay, and we see that since they're opposite signs, negative and positive, your solution is going to be negative, right? When you divide or multiply opposite signs, your solution will be negative. So in this case, it's going to be negative 48. All right. Which of the following numbers is not a solution of the inequality 3x minus 5 is greater than or equal to 4x minus 3? So which of these is not a solution of the inequality? So inequalities are actually, they look intimidating at first, but you pretty much solve them just like any other algebra problem. So with my students, I suggest that they actually just replace the inequality as an equal sign at first, and then they can change it later. Okay, so if you're thinking about inequality, I'm telling you, these somebody's hacking me, turning 4s into 9s just on a consistent basis. I don't know who's doing it, but they're very good. Okay, 4x minus 3. And so we're just going to solve this like a regular equation. So we're going to subtract 3x, all right, opposite on both sides. And so we're going to get x here, minus 3, minus 5 is left. We're going to add 3 to both sides. Okay, and then we're going to get x is equal to negative 2. All right, and so now we see that, actually, sorry, x is on the right side here. Make sure to leave it on the correct side so that now when we're replacing it with the original inequality, we see that x is less than or equal to negative 2, right? Or you could say negative 2 is greater than or equal to x. So which one of these does not fit the equation? Okay, x is less than or equal to negative 2. That is not a solution to, oh, right here. A is, sorry, like a little brain freeze, right? So negative 2 is equal to negative 2, so that works. Negative 3 is less than, negative 5 is less than. So negative 1 is the only one that is not less than or equal to negative 2. All right, number 12. Based on the histogram above, of the following, which is the closest to the average number of seeds per apple? So which is the closest to the average number of seeds per apple? Okay, so how do we do this problem? So we see here that on the bottom we have the number of seeds, and on the vertical axis we have the number of apples. So if we were to find out just the total number of seeds per apple, right, we see that we can write these out as such. We have 2 apples that are 3, so we'd write these out as 3, 3. Then we have 4 apples that are 5, that have 5 seeds, so it'd be 5, 5, 5, so on and so forth. So just to make it a little simpler, right, we can just multiply the number of seeds times the number of apples. So we have 2 apples with 3 seeds, this would be 6. We have 4 apples with 5 seeds, this would be 20. We have 1 apple with 6 seeds, that's 6. 2 apples with 7 seeds each, that's 14. And then we have 3 apples with 9 seeds, so it's going to be 27. And so we want to find out the mean, right? So we pretty much want to add up all of the seeds combined and divide it by the number of apples. And I think it tells us here that there are 12 apples in total. So let's just add up all these numbers. So 6 plus 20 is 26, plus 6 is 32, plus 14 is 46, and then 46 plus 27, all right, it's getting a little late. I might mess this one up. I believe it's 73, okay? And so now we just want to see what the mean is. So we have 73 seeds in total divided by 12 apples. So we have 73 divided by 12. So it's about 6 seeds per apple. Very nice. Oh, and thank you, Howard B. in the chat. I believe you were given the answer for the for number 11, so you're absolutely correct. Keep on making your guesses, and it's a bit delayed, so feel free to work alongside. Okay, number 13. This type of problem is super popular. Okay, it basically gives you a table of different students or different people either taking different classes or having some sort of number of pets, and then they ask you to kind of identify exactly what the mean is or percent they're looking for. So pay attention to these if you have a little bit of trouble. So a group of 10th grade students responded to a survey that asked which math course they were currently enrolled in. The survey data were broken down as shown in the table above. which of the following categories accounts for approximately 19% of all survey respondents? Ooh, it's actually, I'm seeing this version of the problem. I like it. So, which of the following categories accounts for approximately 19% of all the survey respondents? So we see how many survey respondents do we have in total? We have 310. So we want to see which of the other categories. Oh, thanks Bianca M for subscribing. Welcome. Which of the categories is 19% of 310? Right. So 19% of 310. Okay. And so to do that, we want to convert 19% into a decimal. And so we're going to convert 19% by moving the decimal place to the left 2 spaces. So it's 0.19 of 310, and of usually means multiplication. So we want to do 310 times 0.19. Let's go to the handy dandy calculator. 310 times 0.19 is about 58.9. Right, so it's about 59. And so we see 59 is right dead center here. So in our case, it's males taking geometry that accounts for about 19% of all of our respondents. Nice. 14. The table above lists the lengths to the nearest inch of a random sample of 21 brown bullhead fish. Of the outlier measurement of 24 inches is an error. Okay, keep that in mind. Of the mean, median, and range of the values listed, which will change the most if the 24-inch measurement is removed from the data? Okay. So which will change the most if it's removed from the data? So right off the bat, I could see that it's without even doing any calculations, it's probably going to be the range, right? Why do I think that? Well, first of all, they tell us that 24 inches is an outlier, right? It's way above what it should be, right? And so range, we understand, is the difference between the highest and the lowest values. So if you take out 24 from the data, the difference between the highest and the lowest is going to change by a lot, right? It's going to go from being 24 minus 8 to 16 minus 8. That's a pretty big difference for this data set. The mean, it'll probably change a little bit because you're taking out a big number out of it, but it's not going to change as much as that range will. The median's probably not even going to change at all, right? Because we see the middle values here are all 12s, and maybe 13 could be a middle value. So it's going to be either 12 and a half or 13 or 12. So that's probably not going to change so much. All right, and they're definitely not going to change by the same amount. So that is why I believe range is most likely going to be a solution for this problem. Okay, 15, 16, got about a half an hour left. So if you have any questions, ask them now or wait until next Tuesday's stream. And so it's actually pretty cool. I was thinking that as the sun goes down outside, the stream lighting would be pretty bad. But it seems that my computer's going on flux as I'm saying this. Wait a minute. Actually, yeah, it's hilarious. Wait, let me disable flux for a second. Okay. So actually the computer screen the LCD screen is bright enough to just lighten the whole stream. So that's pretty cool. Let me actually turn on this light in the back. So maybe, wait. Yeah. Or is this like this weird? I got a bright face going on here. All right. We'll leave that for now, and we'll see. We'll adjust it maybe for next time. But this looks good. It's encouraging. I don't have to use a huge lighting set to keep me illuminated. Okay. Back to actual SAT stuff. Questions 15 and 16 refer to the following information. Total cost of renting a boat by the hour. And the graph displays the C. And honestly, I could have predicted this question from a mile away. Right? When you see these types of graphs and renting boats or going on a taxi, they'll always ask you about the y-intercept here. What does this value mean? And it's always going to be something along the lines of the cost of, or the initial cost of using blah, blah, blah. So in this case, it'll be the initial cost of renting a boat. right? So even if you rented the boat for 0 hours, you're going to still be paying $5. Okay, so they'll many times ask you about that in these sort of problems. So look at this. What does the c-intercept represent in the graph? And they're calling it a c-intercept and not a y-intercept because this is the c-axis in this problem. Cool. So it is A, the initial cost of renting the boat. Again, you could pretty much predict this problem on almost every SAT. In some version of it, they'll have it. Usually with a taxi or maybe like renting a video or something. I don't know. 16. Which of the following represents the relationship between H and C? So they're basically asking for the equation of this line. Well, the y-intercept we know is positive 5. So chances are we're going to want plus 5 in one of these. So A is out, D is out. Okay. What is the relationship? So what is the slope of this graph? Okay. So let's try to figure that out. Let's pick 2 points, right? We have 1, 8, and we have 2, 11, right? So it's rising by 3, and it's running 1, right? So it's rising by 3, and it's running 1. So our rise over run is equal to 3. So the slope of this graph is C, or is 3. And sorry, I'm simultaneously reading Howard B. I think the 0 point shouldn't be colored in. Where's 0 point colored in? Oh, I see what you're saying. That this right here should not be colored in. I don't know. I guess this is just a regular dot or line graph. But yeah, I don't even know why they're putting in these points just every hour. You could read it either way. 17. The complete graph of the function f is shown on the xy plane above. For what value of x is the value of f of x at its minimum? So if this entire line is f of x, where is it at its minimum? Well, we see down here, it's at its lowest point, at its minimum. And they're asking, what is the x, what's the value of x at this point? Well, if x is 0 here, -1, -2, -3. X is -3 at that minimum. Actually a pretty easy problem for number 17. Maybe it'll get more difficult as we go along here. 18. In the xy plane, if 0, 0 is a solution to the system of inequalities above, which of the following relationship between A and B must be true? If 0, 0 is a solution to the inequalities, aha. So they're basically saying if 0, 0 works for x and y in both equations. So we can basically rewrite this as 0 is less than 0 plus a, and 0 is greater than 0 plus b. So if we want to simplify this, all it's saying is 0 is less than a, and 0 is greater than b. So now let's not mess this up, right? This one is tricky enough that we can probably put a silly answer here. So a is greater than b. Well, a is greater than 0 and b is less than 0. So this looks good. This looks good. I just want to be sure. B is greater than a. So it's probably not true, right? Because b is negative and a is positive. So that's not true. The absolute value of a is greater than the absolute value of b. That's actually not true, right? Because if a is positive 1 and b is like negative 8, 8 is going to be greater than 1. So that's out. And a is equal to negative b. And that's not necessarily true, right? They could be any number greater than or less than 0. All right, so I'm pretty happy with a here. If I'm wrong, oh man, they got me again. Number 19. A food truck sells salads for $6.50 each and drinks for $2 each. The food truck's revenue from selling a total of 209 salads and drinks in one day was $836.50. How many salads were sold that day? So if you have not been living under an algebra rock for the past year, this is a very, very common type of problem, especially using food, like they'll use, I don't know, hamburgers and fries or hamburgers and hot dogs, but these are pretty much done in the same way. And the way that you solve these is by setting up a system of equations. So how do we set up the system of equations? Well, first we want to set one of these to be x or y, or in this case we could do d and s, right? So d is going to be equal to number of drinks, s is going to be equal to number of salads, and this is sold, right? Number of drinks sold, number of salads sold. So we see that they sold a total of 209. Okay, so they sold the number of drinks sold plus number of salads sold is equal to 209. So that's our first equation, easy. The second equation talks about the price. We see that salads cost $6.50 each and drinks cost $2 each. And combined, they sold $836.50. So if we were going to set up the price equation, we see that 2 times the number of drinks, right? Because you make $2 from every single drink, plus 6.5s, right? You make $6.50 from each salad. Combined, you just made how much? $836.50. So how are you going to solve the system of equations? So in this case, maybe elimination would be a little difficult, right? So we want to find out, we are going to use substitution in this case. So we're going to isolate one of these variables, d or s. In our case, let's substitute for d. So we're going to say that d is equal to 209 minus s. Now how did I do that? Well, I just subtracted s on both sides in this first equation. So now if you see the second equation, I can replace d with 209 minus s. Anywhere where you see a d in this equation, you can replace with 209 minus s. That's what it means by substitution. So I'm going to replace this and do 209 minus s plus, oh man, I'm not going to have enough room. Wait, sorry, let me rewrite it here. So 2 times 209 minus s plus 6.5, wait a minute, I'm on delay now, 6.5s is equal to 836.5. Okay? So we're going to distribute this, right? So let's do it quickly. So it's going to be 418 minus 2s plus 6.5s is equal to 836.5. All right. And now what's 418 minus 2s plus 6.5s. So if we want to combine these two right here, it's going to be 4.5. Freaking out. 4.5s. And then we're going to subtract 418 on both sides. So what is 836 minus 418? Let's not mess this up. I believe it's 418.5. I think that's right. And then we're going to divide this by 4.5 on both sides. Bam, 4.5. So what's 418.5? 418. Wait. 418.5 divided by 4.5. 93. So it said how many salads were sold that day? S is equal to 93. Bam. And if you want to find out how many drinks were sold, well, we know combined they sold 209, right? So you can just figure out how many drinks were sold. All right, 15 minutes left. Our final stretch here. Let's see if we can get some difficult problems solved. Number 20. Alma bought a laptop computer at a store that gave a 20% discount off its original price. The total amount she paid to the cashier was $P. including an 8% sales tax on the discounted price. Which of the following represents the original price of the computer in terms of P? So she got a 20% discount off the original price, and then she paid cashier P dollars. Okay. So in these types of problems, I actually like to use a number for P, right? You could figure it out algebraically, but I think it's just a little bit easier to put in your own number for P and then substitute it back later in the equation. And you'll see what I mean in a second. So what is a good number to substitute off the to substitute for P, right? Because we're dealing with percents, so chances are you want to use maybe 100, right? 100 would be a good number to use for P. So let's assume that the computer laptop cost $100. Pretty good deal. She got a 20% discount. Okay, so now she got to pay only $80. The total amount she paid to the cashier was P dollars. Okay, including oh, so sorry. So P is actually our original computer cost 80. Okay, so if we're going to be thinking about it that way, right? 100 is the original. 80, okay, is what the discounted price was, and then she paid a tax on top of that. All right, so or included a tax. So what was the price before the tax, right? If 80 includes an 8% tax, how are we going to find out what the original price was? All right, let's think about that for a second. So there's some original price, right? X. Then she paid an 8% tax on X, right? And that all came out to be some sort of 80, right? So if you look at it, we have 1.08x is equal to 80, right? So in order to find out what the original price was, we want to undiscounted price. Yeah. Or maybe, oh, no, I'm sorry. I'm misreading this completely wrong. That's on me, guys. She paid an 8% tax on top of the 80. That's on me, right? So we want to find out 80, right, times an 8% tax, and then we're going to add that back to 80. Okay, so 80 times 8% is going to be 6.4. So she paid in total $86.40. Okay, so we want to relate this back to 100, right? So this is where it comes into play. How are we going to relate back 86.4 to 100? Okay, and so we see that P right here, and I this is in advance, right? You can do this yourself, but we only have about 10 minutes left. We see that we have P over, okay, 0.8 times 1.08, right? So that's going to be, 1.08 times 0.8, 0.864, right? If you did 80 over 0.864, that will get you back to the original 100, which we started with, right? And you could have used any number and it would have worked out the same exact way. Okay, so this was a little tricky, but I'm sorry I led you the wrong way. The wording of this problem was actually slightly, I don't know, weird, backwards. Okay, let's move on. Number 21. The data in the table above were produced by a sleep researcher studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people who observed early bedtimes, and Group Y consisted of 100 people who observed later bedtimes. If a person is chosen at random from those who recalled at least one dream, what is the probability that the person belonged to Group Y? So let's see here. If a person was chosen at random from those who recalled at least one dream. Okay, so at least one dream means they'll be on the right side of this, okay? We want to ignore the people that didn't record any. So Group X is 100 people. From those who recall. What is the probability that the person belonged to Group Y? So Group Y, we see had 79 people in total. Okay, so 79 people out of the people who recalled at least one dream. Okay, and so if we want to see how many people recalled at least one dream, we see 39 plus 125 is 164. So it was 79 people out of a total of 164 people who recalled at least one dream. So that's C. So I think this is actually a good time to stop for today. Again, I will be back on Tuesday at 7 p.m. The stream schedule you could see in the description, but it's going to be Sundays, Tuesdays, and Thursdays from 7 to 9 p.m. If you have any suggestions for material, for topics that you're interested in, we're going to be doing the SAT. We'll be doing a few practice tests for now, but feel free to write them in the chat or message me directly, and I'll try to work them in. All right. Thank you so much, and thank you for joining the stream today.